All right. So I'm looking at that journal entry that I had you guys grab. It's just a fold in half type entry. So 6.4 is all about the angles that we can have in circles. Now we talked about central angles yesterday, and we just discovered the key features of inscribed angles. But now we're going to look at different ways that inscribed angles can happen. All right, and theorems that go along with it. Then tomorrow we're going to continue with 6.4, but we're going to look at some different type of angles. All right. So the very first theorem that we have is what we literally just discovered during class or with the exploragons. So when we're talking about an angle is inscribed in a circle, then the measure of the angle is half the measure of the intercepted arc. So in other words, an inscribed angle, all right, an inscribed angle, we know it's an inscribed angle if it has that vertex of the angle on the circle and its two endpoints are on the circle as well. So this is referred to as our inscribed angle. Now, remember, the intercepted arc is the ice cream to its cone. It's right here. Now, what it's saying is that our inscribed angle is equal to the intercepted arc all divided by 2, or 1/2 the intercepted arc, however you want to put it. But it's essentially just dividing it by 2. So if I gave you the inscribed angle and wanted you to find the intercepted arc, how would you find it? So, for example, let's say this inscribed angle was 30 degrees. What's the intercepted arc measure? So, for example, if the inscribed angle is 30 degrees, that's its measurement, what's the arc measure? 60. You would multiply it by 2 to get to the intercepted arc, and vice versa. So if I gave you the 60 first, the inscribed angle would be 30 because you would divide 60 by 2. All right. So now let's look at some examples that go along with this specific theorem. So on the inside of your foldable, look at example 1. So given that the measure of arc BC is equal to 120 degrees, we want to find the value of x. Now, where would arc BC be? So where's arc BC? It's to the right in between the letters B and C. Now, since we're only naming it by 2 letters, is BC a major or minor arc? It's minor. So does that mean I'm taking the shorter path or the longer path to B to C? The shorter. So that would be over here. So this is arc BC, which they told us is 120 degrees. Now, the question was to find the measure of angle X. So a lot of times with circle problems, it's never as easy as they give you the angle, you got to tell me what the arc is. You kind of got to work around to get to that. But this one's actually fairly simple because we need arc. What arc do we need to find angle X? AB. So we need this arc right here. We need the measure of arc AB. We need to find that first in order to find the measure of angle X. All right. How do you think I can find the measure of arc AB? I'll give you a hint. We're going to use some stuff that we talked about yesterday. How'd you do it? That's exactly what you should do. Why can you take 180 and subtract 120 to it to get AB? It's a semicircle. This segment right here is a what? This segment goes from end to end of the circle and also goes through the center, which makes it a what? Diameter. So if this is a diameter, that means it's doing what to the circle? Cutting it in half. And if you look, AB and BC should add up to 180. So if arc AB plus arc BC equals 180 degrees, that means we can subtract 120 from 180 to give us AB, which would be what? What's 180 minus 120? 60. So my arc measure is 60 degrees. So this is 60 degrees. Thus, to find my inscribed angle, I have to do what to get angle X? So we just said it earlier. We have the intercepted arc. How do I get the inscribed angle? So how do I get this angle right here? If I'm given this arc. Blake, what you think? Divide it by 2. Good. So since this is an inscribed angle and we have its intercepted arc, we just divide it by 2 to give us the inscribed angle, which is 30 degrees. So the measure of angle X is 30 degrees. All right. Now let's look at example 2. This one has a little bit of algebra in it, which that's okay. It's not too bad. So we're given the inscribed angle here because its vertex is on the circle. And we're given a value or an expression as the measure for its arc. And it wants us to solve for X or find the value of X. So in other words, we got to solve for X. Using the information that I know about inscribed angles and arcs, its intercepted arc, how can I set up an equation to help me solve for X? So first off, could we figure out what this arc measure is? Do we have enough information to figure out what this arc measure is? So what's this arc measure? What is it? Nope, that's the angle measure. 172. How'd you get 172, Landon? Right. We have the intercepted angle. So to get the arc, all we got to do is multiply it by 2, which gives us 172 degrees. So this arc is equal to 172 degrees. So guess what? There's our equation right here. We're going to do 1/3 times 9x plus 3 is equal to 172. Now, there's a couple of ways we can go about this. What do you want to do first? So first, we got to mess with the 1/3 in some way. So we either have to distribute it or we need to multiply for its reciprocal to the other side. Which one do you want to do? Distribute it. Because if we're multiplying a number to 1/3, what are we essentially doing? We're dividing by 3. So what's 9 divided by 3? 3x plus, what's 3 divided by 3? 1, and that'll be equal to 172. Then from there, it's just a two-step equation. I subtract the 1 to both sides. I get 3x is equal to 171. Divide both sides by 3. What's x equal to? 57. Now, it's not 57 degrees because it's not an angle measure. We just wanted to solve for x, so your answer is just 57. Any questions on those two? All right. Let's look at another theorem for inscribed angles. So theorem 2. And it states that two inscribed angles of a circle are congruent circles, intercept congruent arcs or the same arc, then the angles are congruent. So that was a mouthful, but let me explain how it works. So if you have two inscribed angles, all right, that either intercept the same arc or they are connected by the same vertex for the most part, then those are congruent. So essentially it's saying that if we have two inscribed angles, which my inscribed angles would be right here and right here. Now, those two are my inscribed angles. So again, it's here and here. What's so special about those two angles? What's so special about their arc? It's the what? So what's so special about that arc? Or arcs? Is there an arcs in the question? Guys, what arc does this intercept? So let's, for example, call this A, B, C, and D. What do the arcs intercept? What arc does those two inscribed angles intercept? AD. They both have ice cream at AD. Because if you look, this angle ABD has the same arc as ACD. They both share the exact same arc. So by logic, if they share the same arc, what's true about their angle measures? They are what? They're congruent. So these two angles are congruent. So since angle ABD and angle ACD intercept arc AD, then that means that angle ABD is congruent to angle ACD. Does that make sense? If they share the same arc, logically speaking, they have to be congruent. Also, if they were recognized as congruent arcs, those angles would be congruent. All right. Now, let's look at some examples dealing with that. So look at example 3. So it's saying in circle Q. So that means that this center is named Q. The measure of arc ST is 72 degrees. So this arc measure right here is 72 degrees. And it wants us to find the measure of angle 1 and the measure of angle 2. So here's 1, Here's 2. They're these little angles right here. What's true about those 2 angles? What do those 2 angles share, guys? An arc. All right. Angle 1 would be here. If you look, it forms arc ST. Angle 2 is here. If you look, it also forms arc ST. All right. So if both of their arc measures are 72 degrees, that means that their measure is what? What's the connection between the 2 angles? They're what? They're congruent. So they're equal to each other. Thus, how do I find what they're equal to? I do what? I have an intercepted arc and I'm trying to find an inscribed angle. What do? Divide it by 2. So I do 72 divided by 2, which would equal what? 36 degrees. So that's the measure of both of these angles. You guys kind of getting this? You're pretty quiet today. All right. Now, this one's a little bit harder, but we're going to find the measure of angle 1 and angle 2. All right. Now, angle 1 is here, angle 2 is here. Now, we know that what do these tick marks right here mean on these segments? They're what to each other? They're congruent. All right. So if those 2 segments are congruent, and we got an angle that's congruent, could we say that they're congruent triangles? Why? Is there another set of angles that are congruent? Yes, what are they? What are these angles called? Vertical. So if they're vertical, they're congruent. Thus, those 2 triangles are congruent by angle, angle, side. All right. Now, here's where it gets interesting. So we can kind of work our way around to what these arc measures are. All right. So we do have a set of inscribed angles that do intercept one of the given arcs. Which arc has 2 inscribed angles connected to it? The 125 or the 55? The 55. So the inscribed angles connected to the 55 are right here. All right. Why is that important? Well, can we not find them? Can we not find those 2 angles? Yes, we can. So, if this angle is 55 divided by what? So if we do 55 divided by 2, what does that give us for these 2 angles, the green angles? 27 and a half. All right. Now, The next thing we could do has to deal with those two congruent sides. What's so special about that congruent side? About one of the congruent sides specifically? So specifically, what's so special about this congruent side? The arc is what? So the piece of the circle that it creates has a degree or an arc of 125 degrees. So what does that mean about here? It's 125 degrees. So another rule is that if a segment creates a piece of the circle that's 125 degrees, a congruent segment can create the same arc size. All right. Now, why is finding that important? What arc do we need to find angles 1 and 2? It's the last little piece I haven't highlighted yet, right? Right. So this piece right here is what we need to find in order to find angle 1 and 2. Why do we need to find that piece? It's the what? It's where those two angles intersect. Both of these angles intercept at the orange arc. So I know 3 out of 4 pieces of the circle. So what can I do to find that angle measure? Right. So you take 360, because that's how many degrees are in a circle, and you subtract whatever 125 plus 125 plus 55 is. All right, so go ahead and do that. Tell me what you get. Get what? Yeah, it's 55. So this is now 55 degrees, even though it does not look like it should be 55 degrees. It's not drawn to scale. All right, so this is 55 degrees. So what's the measure of angle 1 and angle 2? If I got its intercepted arc, how do I find it? You divide it by 2, which we already did up here. So that's 27.5 degrees. Guys, with a lot of these problems, you've got to go around your butt to get to your elbow. I'm telling you. All right. We're not done, so. Cool.
No, I'm with you right there.
All right. The next theorem is that if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. Why is that true? This inscribed angle intercepts a semicircle. So this is the semicircle. Why is it true that it's going to be a right angle? Right, because the arc measure of a semicircle is 180 degrees. And what's 180 divided by 2? 90. So that's why this is 90 degrees. Now, we know it is intercepted by a semicircle because it crossed the ends of the angle hit the what? What's this line? The diameter. Good. So if we're answering questions about this, number 5 is very easy. What's the value of x? 90. This is a semicircle, so this is 180 degrees. 180 divided by 2 is 90, so x is equal to 90 degrees. Sweet, simple, to the point. All right, now, I now need to find the value of x. So, we are given two different angle measure expressions, here and here. What's special about this angle right here? It's 90 degrees. Because its intercepted arc is right here, and that's 180 degrees. Now, what do all three of those angles form? A triangle. What's special about a triangle? It equals 180 degrees. So, if this is a triangle right here, even though it's in a circle, the rules of the triangle still apply. So, a triangle is equal to what? 180 degrees. So, this entire triangle is equal to 180 degrees. So, how would I set up an equation to solve for x? If all three angles have to add up to 180, how would I set up an equation? Say it again. You can start there, yes. So do 180 minus 90. That will give you 90. So that means these two angles have to add up to what? 90. So these two angles, if you add them together, they would add up to 90. So you could do 2x plus 9 plus 4x minus 3 is equal to 90. That's simply because if we subtract these two angles, or the 180 from one angle, that will tell us the combined measurement of the other two angles. So 180 minus 90, that's 90 degrees. So what's my first step for solving this equation? Combine like terms. So I got combine my x's, combine my constants. I get 6x plus 6 is equal to 90. Then what do I do? Minus 6, I get 6x is equal to 84. Divide both sides by 6. X is equal to 14. Another way you could have done it as well is, since you know that all three of these angles add up to 180, you could have done 90 plus 2x plus 9 plus 4x minus 3 and set it equal to 180, and that would have given you the exact same result. So there's a couple of ways you can set up equations. That's one of them. Come on, guys, we're almost done. Hang in there. Two more things. Two more questions. One more theorem. All right, any questions on the first three theorems? All right, the last theorem deals with an inscribed quadrilateral in a circle. And the inscribed quadrilateral is made up of inscribed angles. So this is theorem 4. And all it means is that if a quadrilateral is inscribed in a circle, meaning all of its corners are inscribed angles, then the opposite angles are supplementary. First off, how do I know what opposite angles are? Opposite angles are what? How do I know if they're opposite from each other? They're on other sides of the shape. Can you be more specific?
Opposite sides of the shape. What other specifics are there? What other words do I use?
They're diagonal from each other. So, opposite angles are diagonal from each other. So let's call this quadrilateral ABCD. So what two angles are supplementary to each other? So if I have angle B and I add it to what angle, would that give me 180 degrees? D. So if I have angle A, what angle do I add it to get 180 degrees? C. The opposite angles of an inscribed quadrilateral are congruent. Not congruent, Lord, supplementary. And remember, supplementary means it equals 180 degrees. Or adds up to 180.
What is this color mean?
Now, guys, we're almost done. Now, we're going to find the values of x and y. First off, do we have enough information to find x and y? Yes. How can I find x? It's diagonal from 55. Thusly, I would do what? X plus 55, and it'll equal what? 180. They're supplementary. So I'll subtract 55 from both sides. X is equal to 125 degrees. What about y? What's its connection? Someone different. Y is connected to the 70, so we do y plus 70. It'll be equal to what? 180. So subtract 70 to both sides. Y is equal to 110 degrees. Thus, we found our two missing angle measures. Any questions on that one? All right, last question, and then we're done. Yay. Mariana just put it on my desk. So, for number 8, it wants us to solve for x. Well, I got two expressions with x in them. What's special about those two expressions? Landon. They add up to 180 because they are opposite angles. So since they're opposite angles, they can add up to 180. So I'm going to do x plus 5x plus 24 is equal to 180. So what do I need to do first to solve? Add the two x's. So this would be 6x plus 24 is equal to 180. Then what do I do? Subtract 24 to both sides. I get 6x is equal to 156. And what's my last step? Divide by 6. So x is equal to 26. All right, any questions on any of the inscribed angle theorems? So tomorrow we're going to continue with angles and circles, but we're going to deal with angles formed by secants, tangents, and intersecting chords. All right. So inscribed angles and central angles, these are the easiest ones. All right. So you need to know that a central angle is equal to its intercepted arc. An inscribed angle is half its intercepted arc. All right. So for the rest of class, you can work on the delta math assigned to you. So that delta math, you should be able to do anything that says central inscribed angles. All right. If it doesn't say that in the topic, don't do it yet. All right. So just do the sections for right now that say central and inscribed angles. Yes. Yeah. And I'll go ahead and post your exit ticket as well.